yesterday class.
Yesterday?
Yesterday we have class.
No, yesterday we planned, I think mentioned that you will not be able to join, so we canceled.
Yeah, yeah. Okay. Yeah, actually I'm not feeling well. I thought Ravi also will join, so I just told him in advance.
Okay. So on the tool side, we covered S3 bucket, where we stored about copy, sync, and how to create bucket. And then some more commands were there for moving the files and then dropping the bucket, all that thing. So those are like S bucket. It is very important. Like S3 is our primary storage. So in data lake, we talk about data lake because all kind of data can store there. So S3 bucket is something which we use because let me reshare. Yeah. So S3 we discussed. I think you will not be able to share now. Just a moment. Okay. Still, I think I'm not able to see the screen, right?
There is a breakage in your voice continuously.
Okay. Yeah, I think so. We discussed about S3 bucket, and then after S3, we also discussed about RDS. RDS is another service for database where which we use for SQL and Postgres mainly, but we notice that there are like 4 other engines available: Microsoft SQL Server and Oracle, Aurora. So those were other engines available, and we also like understood how we can create the database and connect to it. So all that connected to the SQL session that we had. So in SQL, this also briefly touched. They I explained like how ingest the data into from the CSV file into the database in cloud. But last time also it was like giving some issue. I think let me try another network just a moment. I think now it will be clear, right? Okay. So
Yeah, it's
we
clear. Clear. Yeah, it's clear now.
yeah. So we discussed S3 bucket where we like S3 is the most important because of its storage. So in data engineering, we need to store the data regularly, and S3 bucket enable us to store on cloud at scale and in any form like objects. So it could be structured, unstructured data, semi-structured. It doesn't matter. We can store any kind of data on S3 bucket at any scale, terabyte, petabyte. So that is the power of S3. And then another tool we understood is RDS. RDS is a service which we use for databases, and we need to what happens like along with the unstructured data like we store in data lakes in S3, we also need to store the data in a structured manner because when we need to analyze the data, we have to run queries, SQL queries. So that SQL queries we cannot run in S3. We need some kind of database engine, and RDS provide that. So we can also load our data from unstructured to structured format in tables in RDS. So in RDS, we can create databases like Postgres, MySQL, and those databases enable us to run our SQL query so that we can analyze. So in our SQL class, we also like understood. I showed you that we have some CSV files, and those are like raw data. So once we have those CSV files, our goal was to upload it to some database on cloud. So I at that time I showed you the Python code, and we also go through that like how we can enable this process where we want to upload the CSV file into some database. And then in this part RDS, I also showed you how to create your own database. So it was like one simple process that we need to follow to like create our database. And if you remember, like I mentioned about two important points, like one is the public access enable that we need to make sure, and another was security group. So in security group we have to enable like allow all the inbound traffic from all IP addresses. So those are like two changes we make so that we can connect to databases. In my case, what I do, I mean, whenever I join some project, in each project, they have their own set of infra, including databases, S3 bucket, account, and all. But for my learning, also because I cannot rely on someone else's account. So in my case, also, my RDS based MySQL and Postgres keep running. So it is running for years now, and they are like very reliable. They even in S3, I store all kind of data. So you might have noticed that in SQL also I showed you that all the CSV file that I had I stored in my S3 bucket. Similarly, I mean these are all reliable services which actually handle billions of dollars of values every day. So they are like super reliable. RDS is for databases, and then another service we discussed is Redshift, which I mentioned is like depends on the same engine, which is Postgres, but on top of that there are some like layers which make it kind of a warehouse. So there we discussed about what is the difference between database and warehouse. So databases is like OLTP, online transactional processing, where we focused on the row level records. We update the row, we delete the row, we add the row, and in warehouses it's like column. So we deal with the column. So data is also stored in the column by column manner. So that the reason is that OLAP warehouses are like OLAP, databases are like OLTP. Whenever the analyst team or the analyst need to run some queries for data analysis, so they have to use warehouse because they can run the same query on OLTP or databases, but it will take a lot of time because there are like huge number of content data. Tables are super big in GB, TB, and then when they run some query, and if they do not want to like I mean read all the records but only some of them, so what happens in production, you might have like hundreds of columns in a single table. So every table you will notice that generally they are easily cross hundreds of columns. So what happens if you want to read some data from database, you need to first read the full table. and only then you can pick particular columns that you want to analyze. But in warehouse, because of data is stored in the column by manner, you can easily pick those particular columns because the data is stored in that way. So that is a major difference between row and column format. And another is that OLTP is not for large data, big data. They are for transactions only, where keep recording your transactions and they support terabyte of space also. But beyond that, do not expect to store them petabyte of data. No company generally store those huge amount of data in transactions databases like Postgres or SQL, MySQL. So they generally use warehouses for that. And what they do, data engineers come here to they build some EL pipelines where they extract the data from the databases regularly, like every day, every week, every hour, depends on the frequency and the requirement of the business, and they keep loading into warehouses. So it's like that. Another difference between database and warehouse is like a central repository where the whole company you can we can like rely on that. Like there is a warehouse where we can load the data, get the data from. So all that include the, I mean, create some kind of reliability. So that is like two three main points. And we in Redshift we noticed that um, we have like a, I mean, I also showed you like serverless mode of that Redshift, and I we discussed about that also. Like because in interview you have to mention all these points that whatever I'm telling you, and even serverless also, that is important because in serverless, what is the benefit of that over the cluster mode of Redshift? And otherwise, I told you that, yeah, I mean, from connection perspective and all their working, both are same like database and warehouse, because even in connection also we use psychopg library, because Redshift is like on top of Postgres engine, so they work like almost same from the interface perspective, but underlying they have a different layer where they are making the data as OLAP. Then once we discussed all about Redshift, then we also switched to Glue. And in Glue, I told you like there are like couple of services. One is crawler, another is database, and then we also discuss one major difference between one pipeline, which is Redshift kind of a storage, and another is via Glue. So I told you that Glue also has some kind of database service, and I showed you about, I think, by some example. So I showed you that Glue crawler. I think I showed you one refined data lake crawler, where but that also will continue today. So that crawler is actually help us to like understand the data automatically. So instead of us loading the data and then loading the schema of the data, crawler is helping us to do that. So that also is something we use in our day-to-day work, because there are like a lot of data comes, and to save time and effort, we use crawlers to like crawl the data in S3 bucket and understand the schema and also register the schema for us instead of us doing the all these activities. So that is the pipeline where S3 Glue, because data is stored in S3 bucket, and Glue, who is handling the catalog part. Catalog means metadata. So data will not move from S3. For example, if you have 10 terabyte of data into some of the tables, the data we do not need to move, because in that sheet what was happening, we need to move the data and we need to load into Redshift supportive disk who are attached to Redshift. We need to load the data into those disks. But in terms of S3 and Glue pipeline, here we are not moving the data at all. We are just sending the crawler into that location to understand the schema. And then once the schema is registered into the catalog, then that catalog is like a database now. Database and tables, all that thing. But that actual data is still stored in the S3 bucket. It is not moved. And that is we will continue today also. So let me share my screen. Just a moment, I'm connecting to my AWS. Okay. Yeah, I'm connected. Let me share the screen. Yep. So this is like AWS, and this GUI which is on browser is called console. So console generally, I think, in my opinion, it looks like kind of a terminal command, but I think this is the GUI part they call console. And here we will go to glue. So you can search any service, and also you can list out all the service that they have. Only some of them we use for data engineering, and the remaining also obviously we sometimes use, but those are not core services. I would say those are like supportive services. For example, secret manager. So a lot of different projects use that, but we also use that. But that is something we use for storing credentials. Similarly, a lot of other services are for support, but only some core services are available, which are we need to rely on, because without that we cannot do data engineering. So glue is also one of that service. There are alternative also, but still, I mean, this service actually help us a lot. And then we also discuss from theoretically, like one difference which is like data lakes and warehouses, and then we are trying to combine that into a single thing, which is lake house. So we first for example, in our foundation we covered that there is a pipeline, where ETL pipeline, where we load the data into data lake, then compute it and store the final data into warehouse. But now the new term is evolving, which is like why we load the data into warehouse. Can we not directly receive the final data also in data lake and query from there? So that is something people are actually building on. So they are building something where data we don't need to move into warehouse. We can directly run the SQL queries on the data. So that is something I'm showing you also from the lakehouse perspective. So first of all, I think I will show you one crawler. So for example, if I pick this one, data lake refined, I think last time also this one picked. So what is happening? We create one crawler. To create the crawler is also pretty like again a form kind of thing. Create crawler, put some unique name here, ABC, and then also add the source, which is S3 bucket. Choose that particular location where we want to send the crawler to. And then once we have data, I mean, they will like three total 5 steps. Fifth one is the review, but it's like any kind of prefix you want to mention or configure the settings and all. So once we have like all these things done, you can see something like this. So this is one of the crawler, and we have name, description, and then prefix, which is optional. So I'm saying whatever table you found, just add the refined underscore to that table, and I'm storing in data lake. I also told you that there is no limit on databases. As far as I know, we can create thousands of databases easily with a single click. So it's like, because data is not, we are like not creating here, but data is actually stored in the like S3 bucket only. We are just creating metadata out of it. So here, for example, you can see that there are a couple of runs. So once we have crawler ready, we run the crawler. So what the crawler do, it go to the location, this data source, which is in this case mentioned here. It will go to this location and understand the data. So for example, if I print it out in my terminal, AWS S3 LS, and I need to mention the forward slash also here. Yeah, so you will notice that there are like three folders: services, therapist, and visit transform. So inside each of that, we have like some file, but that file doesn't matter. We store the data at folder level. So each folder is like a table. Inside that, you can store as many files as you want with the same format. And when the crawler complete it, it will convert all the uh, files, individual files, into a single table. It will automatically append all that. So this will be your table. These are three tables, and that is what we can see here. That when the crawler completed, they identified some table. So they identified three table changes, and those tables are registered into this database which you mentioned. This also we can create at the runtime. So if we go to our data lake database, I think data lake, yeah, and we can notice that we have our these three tables: refined, these three tables. Other also, it's like other tables also we can easily store. Different crawlers can use the same database also, that is possible. So the other tables that you are seeing is coming from some other location, from some other crawlers. So that is like a common thing we can use. But these are like something which that crawler inserted or registered. So you can say location is the location which is stored, but the tables is like the three tables that we identified. So if we go to one of the tables, you will again see some schema here. So you can see the location where the data is stored and the format, archive format, and then there are two columns, and crawler automatically identified the type of column also, which is like this. And once we have that, then we go to Athena, and Athena is another service which we use for like running the query. So just like Postgres engine, MySQL engine, Redshift engine, so all that like different SQL enablement. Similarly, Athena enables us to run the query where the data is stored in the S3 bucket. That is like that. So it's like select star from services. Services is like coming from our data lake database. You can see that we have tables here also, that same table. So Athena just pull the information, the same information that we saw. We don't have to do anything here. And we just come here and see our tables here, and we can like run our queries on it. So this particular feature, data lake services does not exist. Okay, I think yeah, refined services we are seeing. The table name is because we added refined prefix, refined services. So what we are doing, the data is stored where? It is stored in the S3 bucket. And when we run this query, this Athena engine, this Athena service, which runs on Presto engine, don't worry about the term. It's like Athena service for SQL. It is actually pulling the data from S3 and then showing us here based on the query. So it's like that. So these three tools, S3, Glue, and Athena, actually create a data lakehouse kind of environment for us. So it's like another pipeline which is also serverless. So we will also like explore more on it. Today actually we are short on time, but we'll connect tomorrow on time. And this one we will stop here then. Also, let me know if you have any question today. I think
Uh,
yeah.
where what is the link so that I can get all those details like in the same website?
Um, like what content?
Like what you said, Athena, Spark, everything you said right in the same Vision Web Services website.
Yeah. So it's like AWS account. So AWS account, if you create like sign up, they will ask for credit card, and but they will not charge you anything. They will just ask for confirmation. And once we create the account, then we can or we can do one thing. If you try that, create your own account, but if you want to practice, I can also like provide you the access to my account. I'm okay with
Okay,
that.
okay,
So yeah, tomorrow I will arrange that. I will share the credentials with you so that you
okay,
can come and practice all the settings in your system also. But
okay,
before running like some heavy competition, just let me know so that I can prepare that environment. Yeah, but you can use these service settings in my account.
okay. And one problem, like I'm trying to practice with Python with the lead code, but what I found is like even for me the easiest questions are like seems difficult.
Yeah,
So
I mean, lead code is definitely something very difficult. So, I mean, for easier, what I would suggest, because you are new, so for easier, like pick one problem and solve it with your best effort. Then learn from the solutions. Like in discussion you will find solution, then learn from them, like what you missed. And then
Okay.
similarly again another problem. So once you solve 50 problems like in this way, by putting hard work, definitely 51 will be easier for you and you will be able to solve it. So our
Okay.
goal is not to like solve them, but to learn from them only. So that is, I mean, everybody do that. It's not like at the beginning they started solving it, but it's like learning first and then we started solving automatically.
Okay.
But this learning phase is very tough. Like you have to again and again like accept that yeah we cannot solve, and then see the solution, learn from that. So that is like the toughest phase.
Yeah. Okay. Means from the discussion we can learn new concepts, right?
Yeah, definitely. I mean, the same problem they are solving from different code. So we can also not only compare, we can actually compare the code. Like, okay, instead of this, we can also use that to solve the same problem, something like that.
Yeah. Yeah. Okay.
Yep. So yeah, see you tomorrow then. Thank you.
Thank you.
Thank you,
Thank
Vazi.
you.
Thank you, Pawan. Bye.
Bye. Bye.
Okay, bye. Thank you.
Thank you.
Take care.